right, today we're going to review how to add and subtract polynomials. So the first thing that we want to look at here is we want to talk about what it means to have like terms. Okay, so like terms means that we can only combine by adding or subtracting terms that have the same variable part. So what is a variable part? What does that mean? So a variable part refers to the exponent and variable piece of the problem. So notice here we have 4x squared. X squared is our variable part. We have to make sure it's identical to this one, which is 2x squared. Those are the same, therefore we know we can add or subtract those terms. Here we have a 2xyz to the third and we have a 5xyz to the third. They are the same, therefore we can add or subtract. We have a squared c, those are the same, and here we have a 7 and a minus 3. Not the same signs, but we don't care about the signs. We can add positive, negative numbers or subtract them all day long. But what matters is they have the same variable part. And in this case, they don't have a variable part at all. And that's totally fine. We can add and subtract those all day long. The next thing I want to talk about is adding polynomials. Now remember, polynomials just means an expression with more than one term. Okay? So this is a polynomial. We actually would call it a binomial because it has two terms. Over here, this would be a trinomial because it has 3 terms. And anything over 3, we just call it a polynomial. Poly meaning more than one, right? And this would be a polynomial. Okay, so what do we do when we're going to add polynomials? When adding, it's super easy. All we're going to do is combine like terms. So we're going to take this 5x plus 3 and we're going to get rid of the parentheses and we're going to bring down our plus sign and we're going to get rid of these parentheses here around the 2x minus 8 and now we have a simple combining like terms problem. Now for me, I always like to draw like circles or something around my figures so I don't forget or leave any of them out. And I always make sure to include the sign in the front, because that sign stays with that term, okay? So if I have a 5x plus a 2x, that's going to give me 7x. All right, and then I come up here and I go, okay, well now I have this plus 3, and I have a minus 8. Notice I'm keeping that sign in front of that 8, okay? That makes a difference. Well, positive 3 and negative 8, when I add or combine those together, that leaves me with a negative 5. So therefore, my final answer is going to be 7x minus 5. Now we're going to come over here and we're going to do the same thing over here. So we're going to get rid of the parentheses, we're going to bring down our plus sign, and we've rewritten our problem now by just dropping those parentheses. So now let's see what we're going to do. So let's start with the 2y to the third. Now I look here and I notice there's no other terms that have a y to the third. So that tells me that I'm just going to bring that down. Okay, there's no other y to the third. Now I go and I look at all my x squareds. Okay, so I'm going to go and I'm going to circle all my x squareds, remembering to include the sign in front. And there's all my x squareds. So I have a negative 4x squared and a positive 1x squared. Remember, if there's no number in front of a variable, there's always a 1. So negative 4 plus 1 is going to give me a negative 3x squared. All right, now I'm going to go to my x's, and this time I might use a box here around my x, and I've got a positive 5x and a negative 3x plus 5 minus 3. And last but not least, I have this negative 7, and I have a negative 6, and a negative means I have a whole bunch of negatives, right? So if I owe somebody 7 and I owe somebody 6 more, then I am in the hole, a total of 13. So negative 7 plus negative 6 gives me a negative 13. You want to make sure that you go back and check that none of your variables were missed or terms were missed or in the problem. Looks like we're good. And you want to make sure that none of your terms repeat. I have a y to the third, an x squared, an x, and just a number with no variable at all. So therefore, I have combined these as much as I can. So let's take a look at a real-world example here, what we might see. It says Jane is training for a triathlon. She runs a distance of 3x miles, cycles a distance of x squared plus 2 miles, and swims a distance of x minus 1 miles. what is the simplified expression that is equivalent to her total distance in miles? Okay, so they want us to figure out the expression here. So we know she runs 3x miles plus she cycles x squared plus 2 plus she swims x minus 1. Now here is our expression, but we have parentheses in there. We have a lot of them, and we do have some like terms that we can combine, so we do need to go ahead and take this a step further. So I'm going to rewrite this by dropping my parentheses, because when we're adding, that's all we have to do. Drop the parentheses and combine like terms. So I'm going to rewrite this. And now I'm going to start with what I always like to do is start with the highest exponent. So I see I have an x squared here. I'm going to take my x's. 3x plus 1x is 4x. And then last but not least, I've got just my numbers. Positive 2 and negative 1 gives me a positive 1. And now we have our simplified expression to represent Jane's total distance covered. Okay, subtracting polynomials, a little bit different. We have an extra step in here that can get a little complicated sometimes if we're not careful. So let's review subtracting. So the first thing we do with subtracting is we know that the first parentheses, it doesn't change. Okay, we don't do anything with this first parentheses. So this 5x plus 3, it's going to stay a 5x plus 3. Here's where things get different. When we have this minus sign in front of the parentheses, it means that we are taking away everything that's on the inside of this parentheses. So it's like multiplying everything by -1, or the shortcut that people like to do is they just change the sign of everything on the inside, because if I multiply by a negative, it's going to be the opposite of whatever it is now. Okay, so if I have -1 times a positive 2, I'm going to have a minus 2x. And if I have a -1 times a negative 8, that gives me a positive 8. So notice this was a positive 2. It's now a negative. This was a negative 8. It's now positive. From here, it's just like we did earlier. We combine like terms. We got a 5x and a negative 2x. And then we have a plus 3 and a plus 8. And we're all set. Okay, not too bad. So let's come over here and let's do the same thing with this one. Again, the first parentheses, we don't do anything with it. We just bring it down and drop those parentheses. Now, for the second parentheses, we are going to bring everything down, but we're going to multiply it all by -1, which means the same thing as we're changing the sign of everything in that parentheses. So this is going to become a negative x squared. This is going to become a positive 3x, because negative times a negative makes it a positive 3x. And then this is a negative 6. So negative times a negative 6 makes this a positive 6. Again, same thing. We have our 2y to the third. We have our negative 4x squared and our negative x squared. That's going to give me a negative 5x squared. Oops. We have our plus 5x. We have our plus 3x. That's going to give me plus 8x. And we have a minus 7 and a plus 6. That's going to give me a minus 1. So really, guys, not that much of a big difference. It's just applying that negative to everything inside this parentheses before we combine our like terms. Now, there's one other thing they like to kind of confuse you with a little bit here, and it's called the closure property. And I don't want you to let this confuse you too much, but basically what it's trying to tell you is that when you add two or more elements of a set of numbers together, using adding or subtracting, you're always going to be an element within that set. And so all that means is if I add together an integer and an integer, I'm going to get an integer. And if I add a rational number with a rational number, I'm still going to have a rational number. Or if I subtract a rational number and a rational number, I'm going to end up with a rational number. So how does that apply to our polynomials? So the thing is this, if you add or subtract polynomials together, you're still going to end up with a polynomial. And that's what they want you to be aware of. Okay, so if I start with a polynomial, meaning an expression with more than one term, I'm going to end up with an expression with more than one term. And here's some keywords to remember. Mono means monomial, one term. Binomial means two, and trinomial means three. Okay? but they all are still considered polynomials, meaning more, okay, all under the polynomial classification. So let's take a look at this final question here. It says, which of the following shows that polynomials are closed under subtraction when polynomial 3x minus 4 is subtracted from 3x squared minus 5x plus 7? All this means, guys, is we're going to subtract 3x squared minus 5x plus 7, and we're going to subtract 3x minus 4. So we know that we just bring down the 3x squared minus 5x plus 7, and now we're going to apply that negative here, right? So negative 3x plus 4. We combine like terms. We have 3x squared. There's no other x squareds. Negative 5x and negative 3. Positive 7 and positive 4. So we have our answer. Okay. Now let's look over here and see which one of these we would select. We know this is a polynomial. Polynomial means more than one term. We have 3. We know this is a polynomial, so we know it's not a polynomial. We may or may not be. We know it is. And we know the correct answer here is 3x squared minus 8x plus 11. So don't let them confuse you. It's not maybe or maybe not a polynomial. It either is or it isn't. If it's got more than one term, it is. Okay? I hope you found this video helpful. If you do have additional questions, please reach out to your instructor and they'll be more than happy to assist. Have a great day.